All right, grasshoppers. Yes, the popular backed by popular demand. The popular one is all popular. Allie's so popular. Allie Krug is back again. Everybody loves her when she's on the show. She's very informative. She's actually a lot of fun too. I hate to admit it, but how are you doing, Allie? Good to see you.
I'm great. How are you? And how are all the grasshoppers?
Grasshoppers are doing good, I think. Yes. Everybody's starting to get a little warmer from most people's places. So just to be clear, everybody, in case I think I screwed up last week about getting on the show. I hate to admit that because I'm perfect, but Allie's an epidemiologist. What else do you term yourself? You call yourself a what do you have? What are your other titles?
Lumberjack and taxi driver and
that's right, lumberjack.
Yeah.
So Allie's a lot of fun. I met Allie down in Virginia. Well, actually, we haven't met face to face. I was down in Virginia Beach, that Wounded Warrior for Life Fund, that I'm with. Her husband is actually in the Navy, still is currently in the Navy. How long has he been in?
I think 29 years.
29 years. Wow, that's pretty good. And what's his title again? What is he works in the new part of it? Is that?
Yeah, it's difficult to explain briefly, but he basically works for Naval Reactors. And he works over at the Newport News shipyard. So his whole career has basically been in the nuclear area and trying to make sure that ships are built and operated according to Naval Reactors safety protocols.
Wow.
I can't speak.
Fairly smart and very smart man. What a smart getting married to you, right? Is that what it is?
I don't know. That might have been a single mistake.
No way. No. And Allie's got two great young men, sons that are, she drives around to hockey all over the world. Wow, you have been all over the world, really, in Japan and all that. So.
Yeah, and thank you for hosting my friends from Japan and one in Hong Kong a couple of weeks ago. That was really fun.
It was fun. Yes, they were good guys. Yeah, very good. It was interesting.
Thank you for that. Yeah, it was middle of the night for them. And one of them looked like he might have had a few sakes already before he joined you.
I think so, right? Yeah. Yes, he did. It's funny you say that.
One looked like he was still ready to go to work, and the other one looked like work was over. They are my good friends. I really enjoyed them, and I continue to hear about how their hockey season went. They just actually had their big graduation ceremony over there, so they sent some pictures, and they do a really nice end of season thing where all the seniors who are moving on are kind of like sent on from the program with a shootout and all kinds of fun games and a lot of gimmicks and just joking around. So it's really fun.
That's fantastic. That's good stuff. So this is my probably most popular show that's ever going to have. It's called the Tom Show today. It's all about Tom. It's really not, but so we want to talk about what's that?
True Grit Life starts with T as well.
There you go. True Grit Life, Tom, and we're talking about T cells today. So first of all, Allie, educate me about what a T cell is.
Well, again, I always like to make this disclaimer that I love research and I love reading, and I read so much, and my brain is so small, I barely actually can cram it all in, and then to get it back out of my mouth is even that much harder. But I will tell you what I'm fascinated with. I'll tell you as much as I can, and then we'll have to dig back in for questions later. So I'm just an epidemiologist, not an immunologist, not a virologist, but I listen to people who know about this stuff all the time, and they're incredible. And I wanted to mention the unsung heroes in the battle against all pathogens, whether they're viruses or bacteria or other cool stuff. I want to talk about phages sometime, but we'll save that, put that in the parking lot for some other week. So T cells are kind of like the first defenders, and there's two kinds of them. There's CD4 and CD8, and I like to talk about the natural killer cells. They're NK cells as well. But when something enters your body, the T cells are part of the first responder network, and they basically say, hey, something's in here and we need to pay attention to it. And they actually carry a part of the pathogen that's entering your body, the antigen. They carry it over to your lymph nodes, which I think we might have talked about one time, which are these things that get enlarged when you're sick, the tonsils. There's some in here, and different, like, imagine your body is a bunch of intersections where things come together, where, your blood vessels might meet. So imagine junctions in your body, good collection points, and the lymph nodes are there, and they collect garbage and debris and other stuff, and they sort through it. And one of the things that they look at is these antigens that the T cells bring back. So the T cells bring back, and I drew this little picture down here, these T cell guys. Am I centered on there?
Yep,
okay. All right. So these little T cell guys go back, and this Easter egg thing, I guess good timing for this, is in your lymph nodes. And specifically, there's some in your armpits too. So if you have gotten infected or even gotten a vaccine in one arm or the other, and you notice something in your armpit is actually a little bit swollen, that could be a lymph node. Your spleen actually has these in there too. These things are germinal centers. Sorry, this is reversed for me. So this is a germinal center, and obviously it's super big in this drawing, but it's just something very small in the lymph nodes. And there's a dark side and a light side, which you can see in here. Mm-hmm. So in the dark zone, many different B cell options are made. And so what they're trying to do is basically create like a lock and key. And so imagine the key is the pathogen, and the lock has to precisely fit the key. And once that match is made with the B cell, it can then go make antibodies that can go back out into circulation and fit precisely with the antigen. So let's just say it's the spike part of the coronavirus. It can fit precisely with it and then get destroyed. So
it destroys the virus.
Yeah. So in this dark zone, so I'm trying to oversimplify as much as I can, but it's extremely complicated. So in here, this somatic mutation, hypermutation, you think of mutations being a bad thing oftentimes, but really it's a good thing. So in the dark zone, all of these different mutations are made so that you have a library of options. Imagine just a whole bunch of different shapes that are similar to the antigen, but not quite the same. And so if that antigen were to have a variant, say, right, we've talked about the variant, say the variant changes the shape of that spike protein just a little bit, in your lymph nodes is a potential option that might fit it, because you're creating all of these mutations so that if something comes into your body down the road that looks slightly different, you might have a good fit for it. And then it goes into the light zone and it tests the fit. And the ones that fit get replicated, and the ones that don't fit die. And so it goes up in here, and see, this is not a fit. This one right there, I have that one blowing up. So it's no good, not a good fit. And then over here is a fit, and that triggers replication of that, a good fit.
So let me interrupt you for a second, Allie. So I'm gonna give you layman's terms of what you said, and you tell me if I'm correct or not. So the T cells will take the virus comes into the body. The T cells take the virus to the lymph nodes, and then all this matching is done. And then if you can find the right match, the T cell takes it back out again into the body.
Well, if you find the right match, then it goes, actually, that's when the B cells kind of take over from there. So the T cells bring it in. It's like, hey, here's what we've got. Can you go make a good fit? And then the B cells are the ones that run back with a good fit. I'm, again, trying to oversimplify. And I really think only experts should oversimplify because it's lost in translation. But I think they have it.
Your body has, so basically your body has the ability to kill the virus on its own.
Absolutely. Right. Yes,
so,
and as a matter of fact, I was just reading a paper, a person who had T cells only, but not B cells, because they had gone through some kind of treatment that killed off the B cells, probably for cancer or something like that. They actually got COVID and survived. But this was one person. It was just an example in the paper highlighting the importance of the T cells in being viral first responders.
So where are the T cells? You had said to me once, so I lost my spleen. So the T cells are in the spleen, they're in the lymph nodes. Right. Okay. So,
yep.
All right. So, wow, that's amazing. So then if somebody has a compromised immune system, you heard that term a lot, is that related to B cells or T cells and their inability to work properly?
Well, the immune system is very, very complicated. And so I think, and actually I was looking at this once, there's all different kinds of ways to describe being immunocompromised. And it's either due to something that you were born with, potentially due to an infection, even due to medication. So it's really like too complicated to distill down into one kind of immunocompromised status. But yes, I mean, it's immune.
T cells and B cells have to work harder then the two aren't really related.
Well, they are related, but it would really depend on what's causing the change in the immune status.
Right. Gotcha.
So like I would do better with an example that I could research first and then come back and talk to it.
No, I like that. That's fantastic. So then if you get the vaccine, how does that interact with the B cells and T cells?
Well, exactly the same. So what I was just describing is the virus entering your body, and the coronavirus comes in and it's got all these spike proteins on the outside. What the vaccine is generally doing, again, this is oversimplifying a little because each mechanism is slightly different, but basically is saying, the thing that seems to attract the immune system a lot is that spike protein on the outside, the red thing that you see so many pictures of. that thing is really an immunodominant sort of antigen. Immunodominant means if you're going to throw something into the immune system, it's going to go, oh, wow, that's interesting, to the spike protein. There is other stuff like the N protein on the outside of the virus that your immune system sees as well. But they decided the best one to trigger the attention best was the spike protein. And so the vaccine induces your body to create a bunch of the spike proteins. And then from there, it's the same essentially. It's the T cells go, oh, here's the spike protein. Let me go show this to the B cells and the germinal centers. And then the B cells go and make all these different variations of it. The best fit comes back out and that proliferates. And that's why you see the antibody levels going up. But the whole point of this conversation is the easiest thing to measure is antibody levels in the blood. It's super easy, really. I might have told you I got it from Quest. I got my antibody levels measured about 2 weeks ago. But T cells are harder to measure, and so that's why they don't get a lot of attention. So one of the proxies for following vaccination in the clinical trials to see how well people are protected was they measured the vaccine recipients' antibody levels. But lately there's been more attention to, hey, how does this compare to people who actually had infection? What are their antibody levels? What are their T cells doing and things like that? So the immune system really benefits from a coordinated response between T cells and B cells. And I just wanted to throw that out there because I don't think T cells are recognized enough.
Yeah, they'll see the T, right? T for top. Okay, I like this question here. So Joseph, he's not that smart of a guy. No, he is. I'm just kidding.
Good question.
This is not a live virus. So how does it trigger T cells? Does that make sense?
So does he mean the vaccine? He must mean the vaccine is not a live viral vaccine. So he's right. What they're basically doing is getting the antigen that I mentioned, the spike protein, into the body in some delivery mechanism. So the mRNA vaccines are sticking the RNA code inside that little nanoparticle and bringing it into the body. The Johnson & Johnson vaccine is using an adenovirus vector, and so it's sticking the code for the spike protein in that. That's a cold virus, so the cold virus then brings it into the cell, and actually all this gets more complicated than I need to probably, but into the nucleus. DNA turns into RNA, turns into the spike protein code, which then produces that spike protein again. So it's all of them are trying to get the cells to actually manufacture spike protein.
Wow.
That's the bottom line. And then there's a final one. Novavax is basically just creating the spike protein out of insect cells. It's growing it out in insect cells. So you're going to get a spike protein only pre-made in that vaccine. And that one's Novavax.
All right. So this happens not just with this virus or these like the pandemic or the coronavirus, but any kind of virus that comes in your body at all, like a flu virus, whatever it is. Right.
Right. I mean, your body is, there's different parts of the immune system, different kinds of antibodies. And one thing that might be interesting for the grasshoppers to know is that we hear a lot about IgG and IgM. IgM is a very immediate response. IgG are the antibodies that you can detect over a longer period of time. And then in the nose and the mucosal membranes and epithelial membranes are IgA. And so in the stomach lining and in the nose, there's IgA. And I like to see that in this paper that I read, the IgA stays pretty high for a long time. So that's like truly a first responder that's already in the nasal membranes.
Well, is there anything you can do to strengthen the T cells and B cells, that whole process? The food you eat?
That question too, and I didn't get time to check into that, but I think, from what you and I have been talking about on your show so often, I mean, everything that you do to benefit overall health will help. I think getting exercise, and I mentioned before that obesity can be a state of chronic inflammation, which is a state in which and again, my nutritionist friend Amy would be much better coming on to talk about this, but I think things that put your immune system in a state of constant high vigilance could be counterproductive. And so, exercising and moving toward a healthy weight and a healthy life and eating fewer things that are high fat and the wrong kinds of fat and things, the less you make your body do to keep you in homeostasis, to keep you in just a natural state of health and able to respond to pathogens, I think is a good thing. But not a suggestion for anybody to go way overboard. It's just promote good health.
And we talk about, I've really gotten into fasting, right? We talk about autophagy, is that eating of itself. So your body's really eating up all the bad things inside. Would that be eating up the bad stuff related to the virus as well, or?
I did see something about that in the literature. I was actually looking to see fasting related to immune function. And like any area of scientific literature, there's going to be an evolving sort of consciousness about what direction we believe the literature is pointing. It doesn't tend to be very black and white. But I did see that fasting did promote good gut health. It caused in your gut, there's a mixture of, we should have Bill Franco back on to talk about the microbiome, but there's a mixture of bacteria in your gut, and some are good for you and some are less ideal to have. And there's a kind of dynamic tension in your gut all the time based on what you're eating, and eating a lot of sugar and stuff like that tends to promote the stuff you don't want as much, and eating healthier tends to promote the stuff you do want. And then to your point about fasting, when you're fasting, you're changing the dynamic, the environment in your gut such that the things you don't want to live have a little bit harder time thriving. And so overall, I think that you're boosting the good stuff and lowering the bad stuff. That was the sense from the little bit of research I did so far.
Very cool. That's interesting. I didn't realize that with the T cells and B cells. And again, so we touched on, so I don't have a spleen. So the T cells, there obviously is no spleen there, so there's no T cells. But with the lymph nodes, they do the same thing as a spleen would do.
Yes. Yep. So I just don't know, you would want to talk to a doctor and just see, more information to your situation specifically. But yeah, you still have T cells. You're Tom, and Lord knows they're probably huge.
And we talk about that because Allie is a great friend and she cares about me. And when you get your spleen removed, you're supposed to be getting a special shot, flu. Well, I can't remember the name of the shot. It was monoclonal. I can't remember what the name of it was. But of course, I do not, because I'm a little stubborn. I think I'm a medical miracle. So. But because Allie cares about me, she says, Tom, you really should get the shot. It was very funny the way you said that day. You didn't try to lecture me, but you were like, you really should get the shot.
I don't even think I said should. I think I said, do you have a good doctor that you
yes.
all over with? And I do give it some thought, because I think everyone's situation is a little different. And I think that, you're focused on a healthy life and being strong and fit and all of that. I do believe strongly that the mind has a great deal to do with your wellness. And when I was sick with COVID, I realized that my brain was trending towards some very negative feedback loops because I was worried because of everything I'd been reading about day 8 and taking a turn for the worse. And, I was actually worried, and I didn't like that feeling. And that's what prompted me to get back into really studying immunology a lot more and virology. Which is something I enjoyed in college, but I really only have one formal class to my name. So I really feel very uncomfortable speaking in any specifics. But I found that the more you learn and the more you teach yourself, the more confident you can be in what's happening within your own body.
Sure.
And so I really think that's important, that we all pay attention to the feedback loops that we have in our mind and our self, even your self-image. We talked about eating disorders once and caring for yourself. I think it's all part of the same sort of general outlook, right?
I agree. Well, we're having a debate. I have another gentleman that's a great guy, Mark Puttenvink, comes on. He was a former strength and conditioning coach with the Rangers and really into fitness. And we were talking about lack of sleep or not getting enough sleep, and how we actually felt like we could function. I should put it another way. A lot of people think, well, if you're not getting enough sleep, you can't function as well. And the science bears out that, in my mind, the science is right. It says that, your body and your mind will not be at your peak performance if you're not getting enough sleep. But our argument was that if you can train yourself properly to recognize, okay, I haven't got enough sleep, so now I know my brain and my body is not going to be at peak performance. Now you kind of elevate your preparation, and you get yourself even more fired up. You get your body and your mind more into the zone, because you know that you're not going to be at peak performance because of lack of sleep. So you can really, and the flip side of it is, if somebody tells you, well, you're tired, you won't be able to play as well in this game tonight. So we were talking about the NHL where they play a back-to-back game. That it's almost like a self-fulfilling prophecy now, because they're saying, okay, you're tired, you won't be able to play as well, so they automatically just don't play as well, as opposed to saying, I know I'm tired, so now I need to prepare even more for the second game in a back-to-back, right?
Right. Do they actually say that to players and stuff? I heard somebody, an announcer, saying man, they don't really have their legs under them. And I'm like, man, I would not want to be playing knowing somebody's saying that I can't get my legs to move under me, because I'm sure I felt running that way like that. And I'm like, man, I am stiff all the time today.
Well, what happens now in the NHL, I'll use the NHL, for example, they'll look at the numbers, and the numbers bear it out that teams have a worse record on the second game of a back-to-back. But again, I think it's because, and then, yes, I get it. There's no question that you're tired. You played a game the night before, but I think it's more, okay, if you say to yourself, I know I'm playing a back-to-back, so I have to be even more prepared the second night than I was the first night. And I think then I find in some ways when I go to the gym in the morning, I'll only get maybe 4 or 5 hours of sleep when I go to the gym. When I'm driving there, I'm getting myself like just the goosebumps are going. I'm more fired up because I know that I'm tired and I want to get a good workout in. And I don't care that I didn't get enough sleep. I still want to get that good workout. So
I felt that way a little bit when I was practicing. I'd get back late from hockey, driving the kids to hockey in Japan, and I would want to get up and run with my friend in the morning. So I'd get up at 5:20. I might have only gotten 5.5 hours of sleep, or say I'd go to kendo the night before, super exhausting and vigorous, and yet really exhilarating martial art. I'd come back all wound up. It would take a while to go to sleep, and same thing. Next morning, I'd want to run with my friends. So I had the same sort of feedback loop in my mind, like almost like self-talk, right? Like, wow, you're being kind of heroic this morning. And that's sort of like, underdogs maybe tend a little bit of power from that. I think that we need to treat ourselves sometimes like with the underdogs. Wow, like no one would have expected you to get up this morning. But look at you. And that can be a little empowering.
I agree. I think that's, you do get all fired up over that stuff. Yeah. Let's talk about the pandemic and the vaccine rollout. Is that going the way better than expected? It's picking up. How's it going?
I haven't panned back to look at the numbers this week. Again, the last time I looked, we had a lot more people vaccinated than we had people with infections. And I just was kind of wondering why that wasn't getting a little bit more attention. I thought that was something good to make note of. I think the concern is that we still have a lot of people who are unvaccinated. And we're reaching now down into the group of people like the 20 to 40-year-olds where a lot of the infections have been, because they're working, they're going to school, they're wanting to live life, they're wanting to resume their lives, they're taking care of business. And so I think the concern is that we're reaching down into that group where we've got busy people who are less high risk and they're going about their lives and their exposures are high. And, the director of the CDC is concerned that we're seeing potentially we're going to see hospitalizations go back up because those 20 to 40-year-olds, they don't have age as that massive risk factor, but they may have other things which put themselves at risk for getting pretty sick. And, they're not potentially not taking as many precautions. But I think as weather gets better and as more people get vaccinated, and honestly, as the infections creep up, the latest projection I saw was natural immunity from having previous infection is not as bad as was once thought. It's maybe around 8 months. So those lines of protection from both vaccination and natural immunity are going to keep pushing the virus back, and we're in a race against time against the variants. So I think that we all need to try to do our best. It doesn't mean wearing masks all the time outside while running. I mean, I'm a very reasonable person. I don't wear masks outside most of the time. But I have had natural infection and I will wear a mask inside, even if it's not strictly required, because I think it shows people that you care about them. No one would necessarily know that I've had COVID and I'm very unlikely to transmit anything. So I think just go about life in a way that's sensitive and reasonable and, showing concern and empathy toward others. And that will go a long way toward kind of keeping opportunities for the virus to get out there a little bit lower while we're trying to get vaccines in arms.
It is interesting. I got a friend of mine I talked to last night out in Vancouver, and they've shut down things again. They've closed all the gyms and bars and restaurants and all again because they had a spike in cases. So I guess to your point, right, people now maybe are getting a little bit complacent, thinking, okay, it's...
Yeah, it's really tough. I mean, I actually did go out to eat for the first time in 15 months. I think I've been out twice in 15 months. And, yes, you can go into a restaurant, but two different restaurants can have very, very different precautions in place. Right. And the restaurant I was in, the tables were 6 feet apart, but there's no magic where you can walk through a restaurant with your mask on, then sit down, and everyone, 200 people in a restaurant eating with their masks down, you can't really assume that, you're not going to run into virus simply because you're 6 feet away. So I think that eating out is still, and the Japanese are saying this, I read their media and their precautions too, and what they're saying, because they've got a pretty good handle on, sensible stuff. Right. And so I read what they're putting out to their folks, and they're like, indoor dining, whether it's in a small group in your home or your apartment or in a restaurant, is still kind of high risk. So think about, are you eating with say you have 6 people. Are you eating with 3 who have been vaccinated and 2 others who've already had COVID? Risk is pretty low. Are you eating with a group of people who are, everyone's in a dual income household, everybody's working, everybody's in high public facing jobs, potentially high exposure? and no one's vaccinated, and does somebody in that group have a risk for more serious outcomes? Are people smoking? Then maybe be a little more cautious. So I think we need to provide people with enough information that they can make their own really well-informed decisions, and not have people just be so tired of the rules that they're just gonna be like, I'm going to the restaurant.
So to touch on that point, so you walk in a restaurant, you have to have the mask on. You then sit down at the table, you take the mask off, you've got to eat. And like you said, all restaurants seem to be different. But let's say you've got this table spread out 6 feet apart, but the potential is still spreading the virus, like just by breathing, right? It's still there.
Yeah, and in particular, breathing, not even so much, but talking is a really great way to aerosolize. Right. And laughing and having a good time. And then you throw in alcohol and inhibitions are down, and people are staying longer and, laughing more and having a great time. That's what we all really want to do. And there's ways to do that. And as the weather gets nicer, like literally just crack a window, literally in your house, crack a window, have your small gathering, but crack the window, or go outside. You know what I mean?
Why did they crack the window? Like getting fresh air circulated?
Yeah. Yeah. It's hugely important. Hugely. And I was kind of frustrated that we weren't talking about that for very long. Like back in March, I released for my neighbors, I made this Allie's Sensible Sanitarium guidelines for how to enlist the teenagers in your neighborhood. This is a year ago when I was worried about, I had already been sick. I was pretty sure I'd already had COVID a year ago. And I was thinking it was already going around pretty quickly on base in Japan because we were half an hour from the Diamond Princess. So I was ready. I was getting ready. And so I'm we need the teenagers to run for food for us because they're super low risk. Make sure that you have, Google Wallet on a teenager's phone so that you can just pay them and they can go get you food. I had this all figured out, and I was studying ancient hospitals and how they were organized for ventilation. It's super cool. The hospital designs that were the architecture that was known hundreds of years ago that we just kind of forgot.
Right. So what do you mean, hundreds of years ago, they ventilated the buildings naturally?
Yeah, they had all the core. There was 5 or 6 different designs that were super interesting. But basically, they would have clean air going across the medical professionals and then the sick patients and then back out. So the wind would go from clean to dirty and out it goes. And then they were even thinking about, well, gosh, where is that wind blowing into the building right next to you? So maybe you want to alternate. People living in houses didn't need to be breathing ventilated hospital air right next door.
Right. So if people want to have a gathering at their home, and let's say it's cold outside, you can still say, okay, guys, bring your coats and jackets. We're going to open up the windows, right? Because we want to be safe.
Around the holidays, I was trying to get anyone to post my 12 tips for having a safe gathering over Christmas. And there was no uptake locally for Allie's 12 tips. But yes, that was one of the basic things. Do you even really need to bring food? Is it possible to sit around and chat and not bring food? It's possible. We could rethink how we do this. Could you bring your own food? Could you bring your own beverages in a little cooler? That way you don't have to all go through the same kitchen at the same time to go into the refrigerator, touch the refrigerator. The less you can do where people are clustered and gathered, when you're cooking in the kitchen, right? You have all your pictures of your buddies up there. Well, in a gathering, that's what happens, right? So you just want to move people out, Maybe I'll do
that. I'll spread that around the house a little bit. Okay, you got it. All right. I'll play Allie's tips for safe Sunday cooking. So I'll spread the guys out around the room.
Right. The house. Yeah. Okay. Or just ask them if they've had their vaccines yet. Are they 14 days after their dose 2?
I do have Donald Trump up there with a mask on, so he's being responsible. But
yeah, bottom line, these vaccines are incredible. The 2 mRNA vaccines are just unbelievable with 95% reduction in symptoms. And all of the vaccines are incredible against, severe disease and hospitalization. Just incredible. So
here's the question I want to ask you on the vaccines too. And this brought up to me. So the vaccine obviously does not stop you from getting the virus. It helps you fight the virus.
Right.
But if you then have the virus, you'll have fewer symptoms supposedly too, correct?
What was the first part of your question?
You have fewer symptoms if the vaccine's working properly, you'll have fewer or maybe no symptoms. You may not know that you've got the virus.
Right.
Now, on the negative side, then, aren't you more likely then to potentially spread the virus because you don't know you don't know you have it and you're not taking any precautions? Is that a possibility?
That's been the theoretical possibility for a while. And, most scientists are super careful about saying, hey, don't worry about anything until they have hard data to say, don't worry about anything. And I think that's leading to a little bit of confusion just about how vaccines work in general. But if you think about it, if you're if you're vaccinated, you're fully vaccinated, and you're exposed to the virus and it gets in, remember we talked about IgA in the nose being one of the first responders? Well, IgA knows to recognize the spike protein. And so from the moment the virus enters your nose, your immune system is ready to respond and ready to tamp it down. And what we really want to do is keep that virus from getting into cells and then replicating. What the virus does when it enters you is it gets into cells and then turns your cells into its own copy factory so it can make more of itself. And so if you're able to limit that from happening, then you don't get the viral replication, then you don't get the opportunity for the virus to make its own mutations, which is where these variants come from. And so just even getting vaccinated will help with the variant spread because we're giving it fewer opportunities to go use your body as a copy machine. Yeah, and then if you think all the way down the line, if you have fewer viral particles replicating, you're not even going to let it go down even further into your throat or into your lungs, which is great. We don't want you symptomatic there. We don't want you getting more complications due to the viral infection, but you're also very likely to not even be symptomatic, which means you're not wiping your nose, you're not wiping it on stuff, you're not coughing. All of those things mean that like you've got lower viral load and you're not doing the coughing, which contributes to spread. And so it just really makes sense that it's very unlikely that people who are asymptomatically infected with the virus following vaccination are going to contribute to spread. But I know that there's studies ongoing right now to put a hard number on that and quantify it. But to be honest, we've never really examined this to this degree of detail before. And I think possibly given that we have a pandemic, we have an opportunity to do the kind of science that we haven't really had a chance to do before because there's so much COVID out there. It doesn't take as long for us to accumulate cases and data points as it would otherwise. So I'm really thankful that the scientists are working so hard and focusing on these questions.
Oh, that's pretty cool. That was a very educational show. I did not understand the whole T cell, B cell thing at all before. When you said we were doing T cell because of Tom, of course I thought it's all about me. But
well, we could come back to it because honestly, our schedules, you and I both got really busy, and so I was all studied up 2 weeks ago, and now I'm going from not studied to live.
Yeah, that was excellent. Well, and I like too. I think it's pretty informative for everybody out there too. So, well, great to see you again. How so? Hockey's all done for the boys and everything, or still going?
No, it's done. It completed successfully. They had a really wonderful season. I believe we completed 95% to 100% of our games and practices. We are in the middle of writing up a paper, I hope, for publication in collaboration with another great scientist who I met via Twitter. So I'm super excited that we'll be able to share some of the protocols that we use to help keep people on the ice and healthy. So stay tuned for that. I'm hard at work on that.
Definitely. And Allie, again, her career is writing. Explain what your career is.
Most of the time, I don't get to play with data directly like I am with the hockey team data. So I'm doing actual epidemiology work right now. So I'm extremely grateful for that, implementing protocols and then collecting data and seeing if they actually worked. But most of the time, I'm helping other researchers who are collecting the data, analyzing it, and then writing up their findings. And it's such hard work for them. You probably can imagine, because you've read these studies, just how much goes into developing the background and all of the references. Have you seen these papers, Tom, with 40 references at the bottom? Yeah. So what I do is try to read through them before they go to publication, before they go to peer review, and help the authors, revise it, tighten it up, make sure it's really coherent, make sure their messages are being communicated well, make sure that right now there's a ton of COVID literature, for instance, but in the other areas that I work on, help them reinforce what messages they want to share and what gaps in the literature exist so that they can say, hey, my study fits really well because it answers this question that wasn't previously understood, or it supports the literature in some way or contradicts some previous finding. So it's a real privilege for me to be able to do that despite moving all over. And I work with people in other parts of the world, like Estonia this week. Oh, so that's amazing.
And so, how do people get a hold of you, Allie, if they want to get a hold of you?
abcmedicalwriting.com.
abcmedicalwriting.com. Very good.
Yeah.
And it was it was a T day today. It was all Tom, True Grit, and T cells.
That's right. And please, Joseph asked a great question. If I did a deplorable job of answering it, or if there's any follow-ups for next week, please put them in the question bin.
I'm gonna have to lecture you one of these days. You doubt yourself sometimes. You are fantastic. You got the information down. You present it well. So enough of that saying that you don't do well. So, okay.
Thank you. Right. It's a pleasure. I love the good questions.
Yeah, good. That's excellent. Good show today, Allie. Good job. We'll see you next week.
Thanks, Tom. Take care.
You too.